open source is everywhere, also at your garden maybe. We have our colleagues, Mark and Rita from Gardena, gonna talk about Sapphire RTOS. Thanks, guys.
Thank you. Good morning, everybody. Yeah, happy to kick off the second day here. Nice that so many people came this morning. Today we want to talk about the Sapphire RTOS and how we use it at Gardena. First I want to introduce where we actually use Sapphire at Gardena, the Gardena Smart System. Then I would like to talk about Sapphire itself, what it is. Maybe not everybody knows it yet here, since it's not an embedded specific conference. Then our journey, where we came from, and then how we adapted Sapphire in our system, and then how we use Sapphire in our team setup internally. This is Reto, I'm Mark. We are embedded developers at Gardena. We are part of the Husqvarna Group, so we are technically a Swedish company with a Gardena headquarter in Ulm in Germany, but we have an office also in Zurich, and we both work in Zurich on the firmware, on the devices. I guess most of you already know what Gardena is. We are a well-known gardening brand from Europe. Maybe the most iconic product we are selling is the famous Gardena connector. But we have our products range goes from irrigation, like shovels, everything you need in the garden to maintain your garden, to trim your plants, and to have fun in the garden. A bit more specific, we also have devices with software. That's why we are here on an open source conference. Maybe not everybody knows the Gardena Smart System. It's like your typical home automation system. You have devices which connect to the cloud in some way, and then you have your backend running, and then you have an app, and then you can control it. And then you can do typical things. You can start watering. You can start your mower. You can also set up schedules. It automatically configures schedules for you. So there is some automation also involved. So I have put some pictures here. We have automated lawnmower. We have irrigation systems. You can have valve controls. You can have also a water computer you put on your furnace to control. And then we have also some sensors, so we can collect data and then improve and automate irrigation on the system. The smart system is on the market about 10 years. Not all the time with software. I put a topology here in the middle. So our smart system consists in the center of a gateway, which is running Yocto Linux. And then it connects on one side to the cloud via Wi-Fi or Ethernet. And then it also has a radio module, which connects via a proprietary sub-gigahertz stack to the devices. The reason for that is that our devices, for example, our water control, uses a double AA battery, and we want to last at least a season, ideally more. So we have quite some power constraints on our devices, and also we have quite some range issues in the garden. Typically, you put your gateway in the house, in the garage, or close to the house where you have Wi-Fi coverage, and then you want to reach your mower, which is like running to the other end of your garden when you have a big lawn. So now let's talk a bit about Sapphire. Let me ask you, who already knows about Sapphire or heard about Sapphire? Oh, nice, that's like about 50%. And who actually worked with Sapphire already? That's a few. And who likes to do some projects with Sapphire and Heaven? So that's one or two. All right, great. Sapphire is a open source real-time operating system. That means it covers the range where typically Linux does not fit on a controller. So you would use it on a microcontroller, like an MCU, but it also covers like MPUs and larger processors. From a memory point of view, typically it starts at around 2 kilobyte-ish, which is already much for some microcontrollers. But it also runs on, you can fit it on smaller microcontrollers, but then you basically run Zephyr without an application. So it makes sense if you have a few kilobytes of RAM to really profit from the ecosystem. Zephyr is like hosted in the umbrella of the Linux Foundation. So, and they incorporated quite some features or best practices from Linux. So Zephyr uses kconfig, if somebody knows it, and also the device tree. And from that, it has a really nice hardware abstraction. So typically, you write your application in a way that it doesn't care about the hardware it's running on. So you have peripheral abstraction, but also MCU abstraction. So you can build one application, and then you can run it on different boards with maybe just by changing some kconfig settings. This is also quite important in the supply chain issues we have nowadays. So you can just quite quickly change vendors. It also is quite corporate friendly. So if you think about Linux, you have the mailing list, and then if you want to do upstreaming, then for some people it's quite a challenge. And also in a corporate IT environment, it can be hard to like get the mailing lists properly running on Outlook. And here Zephyr is hosted on GitHub, so you just add your signed off by your email address, and then you can open a pull request, and then you can easily upstream your patches. And then another point is it has a very active and approachable community, so there are a lot of events, and you get a lot of support. Also the documentation is nice. Now I want to hand over to Reto, and he will talk a bit about where the smart system started and how we got to Zephyr.
In 2016, and a few days before the system got launched, Gardena did not have any exposure regarding IoT, creating an IoT system, maintaining it. So they had to go, or I guess it was a good idea to go with external help. And in that case, it was companies that provided proprietary building blocks to build an IoT system. And the result of this was that we had products out in the market, I still have, that we don't fully understand or control their behavior. So we used a proprietary device development kit, which constrained how we could use the underlying hardware. Like certain features we could just not use. We paid for the hardware. We had needs to use those features, but we could just not do because of the architecture of this third-party dependency. What we could do was like hooking our application-specific code into certain predefined C-based APIs. And it gave us quite some flexibility, but in the end of the day, we were always constrained. Plus, we were also constrained when it came to bugs, like when suddenly watering happens when people don't want watering to happen. And we are responsible to get it fixed, but we can't really. We are depending on external help. That's a not so fortunate situation to be in. Same goes when the device, after 24 days, which has certain meaning, of uptime, starts to just drain all the batteries. And you're on the hook, but you can't fix it yourself. To be fair, the companies, they helped us, we got it resolved, but still it showed how depending we were on those external companies. So over the years, the wish became stronger and stronger that we can grow and become more in charge of our own system. And the most relevant wishes were the that we actually have full control. We wanted to be able to access and meddle with all the software stack, meaning having access to all of the source code and actually being legally allowed to do whatever we want. We wanted to be able to no longer be fixed or stuck with one single MCU type, because this was also from the external company depending. We couldn't just support a different one. We wanted, and this was, I guess, for management really, the submit part, we wanted to get rid of the per device licensing fees. And we gave some thoughts about maintainability or future maintainability. We didn't want to just switch to another system where we are depending on others again or having to do all the work ourselves. And as a consequence of this, we did not want to use any vendor-specific SDKs or tooling, or at least reduce it as much as we could, which meant we did not go, like we went with Nordic Hardware because they really support Zephyr really, really well. But we are not using their Connect SDK. Until now, we are still going with Zephyr main, or the latest release of Zephyr in upstream. Also, we're still so far successful with that, not having any binary blobs, at least not binary blobs that are running in the same address space as our application, so no linking to libraries that are binary blobs only. And what we really wanted is the batteries included, which means we are not rolling our own, and yeah, we could probably get most of the points up there if we roll our own, but then it's all on us, and we didn't want that. And Zephyr totally delivered that. We made the decision for Zephyr in 2020, beginning of 2020. We already tried to enforce a decision or come up with a decision to move on to this kind of second generation system 2 or 3 years before. Back then, we did not, or the technical people could not convince management, but if we did, I guess it would have been Contiki or something else, and I'm quite happy we delayed this decision. So before the switch, starting 2016, pretty much everything in our stack was locked or closed source. Like we couldn't switch the MCU, we didn't have access to the source code of pretty much all the parts in the stack except for our own application-specific code. This is also the part that remained. We still have access to the product-specific code now with Zephyr, but we swapped the application layer for LWM2M. It's an open standard, it's fully open source, it's well maintained by Zephyr. We're still not really happy, and Mark will probably be happy to tell you more about it over a beer. But it works well enough. And the LemonBeat part, this is the proprietary sub-gigahertz protocol, the Find the Mac. We kept it because we wanted to not fork our system. We wanted to remain compatible with all the devices we already sold. We didn't want the customer to buy another gateway. But this time we together with the previous proprietary solution provider, we came up with a shared code base. Like we created a Zephyr implementation, we share it, they use it, we use it, we have all the permissions we need, we can do whatever we want with it, except for open sourcing it. And this is like same company, same people behind, different business model, and it's just a breeze to work with them. Like it's just fun. Like we are on the same level, we can discuss technical problems, we solve them, we can talk about them, about testing, like we have some calls once in a while whenever we feel like, and we profit big time. And before it was just we are depending on them, and they had to reschedule things or prioritize, give the proper priority in their company, and we had a different one for sure, and now we are just able to help ourselves. Plus then on the Zephyr TOS, that's clear, on the lowest layer, the hardware, we have now access, or thanks to Zephyr, we have access to more than 50 MCU families. And right now we are using, I think, 4 at least, which shows like 4 or 5 years later, we actually make use of this flexibility. We already had it before, some kind of platform, the one we bought, but now with the Zephyr solution, we are in charge. And what we came up with is a single repository. We have the different applications in the same repository. We have some shared code, that's the orange part up there. And this repository also pulls in the dependencies like Zephyr and all the different modules that Zephyr already brings from upstream, plus the LemonBeat Radio, which is the code we share with this other company, which is it's neither open source nor confined to our own Gardena specific repositories, but we have it in a shared repository with this company. And all of this is like orchestrated or put together, not with some, let's say, Git submodule thingy, but it's already like the batteries included part of Zephyr. It has a West tooling where you can write manifest file and pull in the dependencies, and it works really well. And like Zephyr has so many things that they thought of before we had to resolve them. Nevertheless, despite all the modularity, it's still quite common, and for us, we do the same. We have an internal Zephyr fork where after every release, we rebase our own patches on top of them. We mark them with some hints for our future selves, whether this patch was just meant to be temporary. So when you look at the patches 2 years later, you might reconsider, or you at least know what the intention was. We leave some hints on whether it was just pulled from most recent main, not yet in the release we are using as of now, or if the intention is to upstream something. And on every update to new Zephyr versions, we rebase those patches and we review those patches, try to nag people into upstreaming things. And keep the list of patches as small as possible. Nowadays, the solution, I think for a few months now, is already in upstream Zephyr, which would be, again, West patch, and that would allow to not actually modify the Zephyr repository itself, but to put the patches you want to have in your own repository and have them applied whenever you check out or update your West workspace. Then, speaking of upstreaming, upstreaming is really, like compared to, I'd say, the Linux world, it's super easy. Like we have pretty much all of our embedded developers made it until have at least one patch upstreamed. It certainly helps that it's like a golden cage created by Microsoft. Now, speaking of us being quite a Microsoft-centric company, it helps to not lose mailing list mails or the like. GitHub, it has a certain advantage in this area. And despite it being quite easy and fun to do, the feedback we get, it's not just, they don't really just approve everything you want to upstream. They actually have quite an impressive CI running. They do have proper guidelines, and they take care that you follow those guidelines. And in case of the Sims reuse support, that's the SoC we used in the first generation of our devices, we added support for it. And it took 3 rounds of trying to get it upstream, but every time the responses were swift, they were fair, super helpful. We got rid of bugs that we didn't know we had, thanks to the community. And I would say this was a success. The second one, it's not so much a success. There I failed quite big time. We it was one of my first attempts at getting something upstreamed. Like when we started, we realized there was a subsystem for settings in Zephyr, and it's great for user settings that change during the product lifecycle. But for factory data, we wanted something that is flexible, like similar to the settings module, but it should not be erased when the customer does a factory reset. And it has some other requirements. And I tried to upstream like an early version of it. It got feedback. I had to rework it. It was clear in the early stage thingy, but then I dropped the ball because I thought other things were more important. I mean, Zephyr totally did their job. It was right. They prevented shitty code from going into their project. But at the end of the day, 3 years later, we still have it internally with us. And even if we would upstream it right now, we already have products out there using the old system. So yeah, if I could go back, I would push it for real because back then we thought, oh, it's too much effort. Let's do it later, and later didn't come. And now we have products out there, and it's getting worse with each new product. So back to Mark.
So let's talk a bit about Zephyr release cycles. So Zephyr follows a time-based release schedule. So they release a new version every 4 months. So and then they have also an LTS version which gets released, I think, 2 to 2.5-ish years. This means that there are no between the releases, there are not necessarily big differences or new features. There are incremental features, and the reason. So we decided that we do not want it to stay on an LTS release, but rather go with every release to keep the gaps between updates as small as possible. So that means also we have some routine in updating Zephyr. We have some scripts in place and also So when I pulled this data out of our Git repository, so there's actually the actual data from when we started with our initial commit back in 2000. So we started with Zephyr 2.4, and then we did quite some updates. Then when we launched our first product, like this irrigation control system, you can see that there are two gaps in the releases. That's just because when you want to get out a new product on a new stack, you want to be exactly sure that everything works, and you want to do some proper testing. So we skipped twice a Zephyr release. But after that, we tried to keep on with the upstream releases. Later, we released Zephyr on the gateway, which already, like the SIM3U microcontroller with the radio module. So we updated in the field all the devices from the old stack to new stack, which is compatible, but now we have the full control. And and if you compare it here, I put the end of life for the 2.7 release. You would see that if we would have stayed on the old one, we would have to skip quite some releases, and then the gap would be quite large. And then it also gets harder internally, from an organizational perspective, you have to plan much more time, and you have a longer time for the update. And the normal releases we just do in the normal work. It's like 1 or 2 days and a bit of testing. And but every rule has an exception. We also have our new mower, the Sileno 3, which we launched just this season. But the team decided they wanted to stay on the LTS for now. That has some internal reasons. Will not go into detail, but you can also see that we progressed further with our repository. As Reto mentioned, we have all our applications in one repository. That means if we do an update, all the devices get the update. So we switch to a new Zephyr version, and then all the teams automatically get the newest Zephyr version. It also makes it easier because when you have some API changes, which happen from time to time, especially in the 3-point area of Zephyr, there were quite some large changes in some subsystems. So you're in the topic, you know what you have to do, so you can do it for all the devices once, and then the effort is quite small, at least I would say. Then some things we really like about Zephyr. We already said it's not just a kernel or like a scheduler and some threads. It's like more an ecosystem. You have a really nice build system. The default is based on GCC, which is also quite a recent version. It's not just some old compiler the vendor gives you. It's it's nicely packaged, which you can download from GitHub directly from Zephyr. But also now West, like the meta tool, Zephyr uses for like everything, like for building, flashing, also managing dependencies. You can use West to install the SDK. So bootstrapping is very easy. Everything is based on CMake. That means IDE integration is more or less there for most of the IDEs. CLion now supports Zephyr directly, so like they support the West format. I don't like their support yet because it's not as flexible as if you would use CMake directly, because they're lacking some features. But I opened the issue there, and they are working on that. At least that's what they said to me. So for the subsystems, Zephyr has a very nice and complete network stack. It's also like they are very focusing on security. So you can have Ethernet, Wi-Fi, it's all included. You just enable it, and your MCU must support it, or your peripherals. And then you have like IPv6, all the network protocols. You get TLS, so it's very nice. You do not have to think about security too much. You just do the best practices, and it works. It's like very comparable to Linux. Then the one feature I really like is the shell. So it's not like you have a shell scripting language there, not yet at least. But Zephyr has a shell, so you enable it with a kconfig, and then you can like log in or type in commands for your MCU, which is not that typical for an embedded device or a deeply embedded device. So and you can also create custom commands. So especially for network devices, you can create your custom device, your command, and then you can send like commands or can control your device features. It's quite handy for development, also for automated testing, so you can instrument your device doing certain stuff, trigger some stuff. Then there's a logging framework, so you can just, like you do not have to like printf everything. So you have logging with different severities, which is quite nice and handy, especially if you're a bigger team, and then some like you have different modules, and you can enable, disable different modules. And then also mentioned by Reto, the settings subsystem, which is very nice. You do not have to worry about a flashware or how you store your key values on the flash. You just use settings, few commands, and then it works. Then which is something which is very important also for connected devices, is updating, and that requires a bootloader typically. So Zephyr works nicely with MCU boot, so they already package it together, and it has really strong also cryptographic support. It does integrity checks, it does signature checks, so we can sign our images, and it just like nicely integrates in the whole system. One thing also to mention is the native SIM. It works like a virtual board, and then Zephyr runs in your Linux process. And it has a virtual network interface and also a virtual console. So you can type in your commands like you would on your device, and you can also like test your networking stuff. So it's really handy. You do not need hardware when you want to develop a network protocol. And on the community side, there is a Discord channel where with a lot of sub-channels where for every subsystem you can get quickly support there. Of course, GitHub issues. There's a GitHub, I think it's called Discourse, like some more forum style. And there are a lot of real-life meetings. We already also hosted one of the meetings in Zurich in our office. And if you're interested in Zephyr, they are happy to also host. They are also always looking for hosts. So if at your company, if you're interested, you do not have to do anything with Zephyr, just have the interest, and then you can connect with Susan Remmert for the community manager, and she also organizes or helps organizing and also organizes speakers. So yeah, it's very nice, and you meet a lot of people. So one of the challenges here I want to talk about is the kconfig. It's quite flexible and a really nice system. So it helps you generating defines or macros to configure your whole system, so you can quickly enable, disable features. But on the other hand, it makes all the flexibility makes it also very hard to control. So kconfig allows you to define your own kconfigs, so you also can enable and disable your own libraries. And then you can have a lot of defaults, and then you have a lot of overrides, so you can have project-specific enables, you can have like board-specific overrides, and then also you can put your own override files on top, and then you can tell CMake, yeah, and on top of all of that, you want to override specific kconfig values. So it can get messy quite fast. So for example, for the defaults, the first default counts. So if you have, during the evaluation, you put some defaults later, it might not be incorporated or end up in the final default setting. And then if you have a lot of overrides, then yeah, so what I want to say is you really have to check in the end what lands in your build. So there is no real enforcement. So we are thinking about, we need some, like a linter, which checks for every build that we can set some specific kconfigs which we really need to have in the final build. Especially we as a platform team, for example, we want to say, yeah, we need at least that much heap space for embed TLS or some systems, and we do not want that other teams are able to override this with their other setting. We had this issue already, so these are kind of difficult bugs to find. For the builds, typically you don't want to have like one build for your product, but rather you might need a build for like the firmware update, you might need some debug enabled builds, and you might also need some builds for during manufacturing, like if you want to enable some, like the shell for controlling some end-of-line tests, for example. So you can use that there. Unfortunately, we built our own build script at the time, so we created we got some inspiration from I don't know where, but we have a YAML file, and then we do we configure all the different builds, and then sequentially it gets built in the CI. But that means it's custom, but there is a twister. It's quite a nice tool from upstream Zephyr, which we might switch to because it's better in parallelizing the builds. Then something also very important, as we talk about a lot of flexibility, is testing. So we want to be sure that all the builds we do actually work. So we had made quite an effort for our platform to test our devices, and not only doing unit tests, but also doing actual hardware tests in our CI. And everybody who tried to test hardware knows it's not easy. Since we have our sub-gigahertz stack, we have a lot of noise in our office because everybody is testing and working with our devices. So 800 megahertz in Zurich bins is not very, So we got these shielded boxes which are quite nice. They are from Ranatec. It's a Dutch company, and it really shields all our test devices so they can work independently and do not interfere between. We also have a big shielded rack in our office, which again shields from outside. So then you get one of the boxes like around 60 decibels, and then the rack again 60. So it really like shields our whole link budget for the transceiver. Then for the other teams, it's like bring your own jig. So we want to test the platform, like radio communication and the basics. And all the device teams are encouraged to build like their own test jigs, which then tests all the device-specific stuff, like controlling a valve, enabling like the HMI, LEDs, and such. And yeah, the challenges here are like flakiness. We have a lot of issues with USB. Just this Monday, I think. Yeah, you have a lot of, as you can see here, we have like a USB hub, and you have a lot of programmers, serial adapters, measurement devices. Most of them are connected through USB. So, and then if just the programmer decides it does not show up anymore on the USB bus, yeah, then you have to rerun, and yeah, it's a challenge. Then on the organizational part, yeah, if you have a lot of hardware testing, you also need to maintain it, and this takes time, so you have to plan for that. And also you have Linux systems which you should maintain. You have dependencies, like we use PyTest, so we need to maintain our Python dependencies. Yeah. So if you want to learn more about the hardware, like the RF stuff and which components we use, there's a nice talk from Reto and our colleague Andreas from the Embedded Open Source Summit in Prague. 2 years ago, I put a link here. They talk a bit more about the devices we are using for testing. And yeah, finally, also quality assurance. We want to have a nice code base, and then we want to. We heard yesterday also Siemens thinks about linting their code. We also put quite some effort into our linting, so we lint basically everything. So. Yeah, we try to get inspired by Upstream, so we want to use all the tools they use on GitHub, and but then also on top of that we use quite a lot of different checkers. So I think there's not a single file type we do not lint. So Zephyr Upstream uses tabs. Our developers want to use spaces, so we decided to configure our linters to use spaces. That's maybe the main difference. And we also check that there are no big files, because if somebody decides to upload a 20 megabytes JPEG file to our Sphinx docu, yeah, that's maybe not a good idea in Git. And yeah, and a lot of other stuff. Yeah, we can talk about all the tools later on if you like. And then, very important, we have also, for most of the linters, we have formatters, so you do not have to find the last space somewhere which breaks CI. You just run the formatting scripts, and then you are fine with the code. And then on top of that, we also have other tools in place, like Parhole to check the structures. And also we collect build statistics in a time series database, so we can track if, for example, a new Zephyr release introduced like more memory consumption for a certain device, stuff like that. So yeah, that's almost the end. So yeah, Reto?
The really last words, the Zephyr totally works, at least for us, and I guess it really does work for many other places too. The issues we have are not related to Zephyr, or not caused by Zephyr, I would say. They're entirely of our own making. And maybe the biggest backdraft is that as a developer, I couldn't really go back to anything else I did before. And yeah, I guess that's the bad part, so to say.
Yeah. So yeah, we have our irrigation control here. If you're interested, I mean, it's just a PCB with a microcontroller and a transceiver. But if you want to have a look, yeah, we can talk about it on the bar, I guess. So yeah, thanks.
Thank you very much. Very interesting for me. One question, you said Zephyr is a real-time operating system. So what are the hard real-time requirements in a garden environment?
Very nice question. Thanks. So since we are not in an automation control and we do not control any motors, we do not really use the real-time part of Zephyr. So there are corporate preemptive and cooperative threads. So you can configure the system, but I cannot tell anything about the real hard real-time. Yeah.
Well, there's one thing. The sub-gigahertz transceiver has a FIFO with 129 bytes, and you should fetch it in time, otherwise you lose the transmission.
I have a question for the migration path. So I would assume you have some kind of OTA over your Lemon Beat protocol. But when you had your proprietary RTOS and then had devices in the field already and then essentially have your customers migrate to your new Sapphire base, did you run into any issues there?
You mean updating old devices to the new stack?
Yes.
So for the devices themselves, we do not update we just introduce new devices. So we build new devices, and the old ones are just software or API compatible. So you can still use the old ones, but the new ones are like you use a different MCU, use a different stack. There's the difference for the gateway because it's already in the field, and there is a radio module which is connected to our Linux module, which takes care of all the sub-gigahertz transmissions. And there it's easier because we can program the MCU from Linux in the field, so then it was easy to update.
Yeah, thanks a lot for sharing your experience here. I have a question. You mentioned the 50 plus MCUs that are supported and so on, but then you also use sub-gigahertz radios and so on. What I heard is that it's still quite limited to get the radio drivers for many of the SoCs, for instance. And what is your experience there? Is it maybe part of this Lemon Beat stack that provides the drivers, or where do you get them if you really want to change your chips?
Well, this part we had to write ourselves. This couldn't use any sub-gigahertz transceivers from Zephyr. And my understanding is there's still no abstraction, like a driver model for PHY drivers. There was some attempt, but it did not go in. So also in the 802.15.4 drivers, they basically program directly the register level or HAL level towards the specific devices.
Yeah, thank you very much for sharing your migration story with us. So if I got it right, you are some kind of central team within Gardena which provides this platform for the development teams. So I would be interested, can you share some details about how you brought the other teams on board? So I guess there were some people who said, well, should we really switch to the new system? How would it change our development cycles? We loved the old features or whatever. So can you say a few sentences how you did that?
It's quite easy. Nobody loved the old system. So there was quite some motivation to switch to something else, which helped a lot to convince other developers. Yeah, that's basically the answer in short.
Yeah, thanks again for the talk. Besides contributing to the community by giving such talks and maybe also contributing your own modifications or enablements, what other kind of contributions do you have in mind or did you consider already for supporting the Zephyr project? I think you're not a member of the project, for example. It's something that you considered or that you are considering, or other activities which go beyond what you need for your daily work. No? Providing test results also for the community, do early testing or something like this. Do you have anything like this already in your mind?
Well, I'm trying to get us to become members for many years. No success at all so far. We did upstream the Sims-Ryu port. I don't think anyone will use it, but at least I'm still listed as a maintainer, so it shouldn't fall on somebody else's feet for now. We did host this Zephyr community meeting, or once in a while we do or every month we try to do an embedded software meetup in the office in Zurich. But yeah, there are some ideas what we could contribute, but to be honest, it's quite low on the list. For example, we do have a when we update modules used by Zephyr West, in upstream we see that you update the commit, the SHA, but usually there is no like log. It says maybe reason X why we update it, and internally we have a small shell script that basically just takes all the subjects of each commit between the old and the new version and makes a nice commit. It helps us, and it's something we should rewrite as a REST command and upstream it. I guess it would help people. There are ideas, but it's like priority, it's too low most of the time. But for specific answers, there's a Git log, and husqvarnagroup.com is what we...
Perfect. Thanks a lot, Mark and Reto.